Hi, everyone. Oh, that's loud. Thanks for joining us this morning here for this talk. We're going to go through our travel, trying to bring air-gap to some of our customers. The talk will be organized this way. We'll start with a short intro, remind people who we are, what we're doing. We'll explain to you where we started from in this journey, how that air-gap challenge came to be, the different steps that we had to take to make a viable solution. We'll go through a small demonstration. Finger crossed, everything should work. And finally, we'll leave you with a conclusion, takeaway, and we'll make sure to keep some time for some question answers in the end. Okay, so maybe let's start with a quick show of hands. Who in the audience knows about Roche, has heard about Roche? Okay. Maybe also just to know, who was a few weeks back in Edge Case? Okay, so you guys know for sure who we are. For the others, so Roche, let's start maybe with who we are, the two of us. So I'm Matthieu Mottet. I'm a senior software engineer with Roche. I'm with the specific Edge team for about 2.5 years now. And
yeah, I'm Hector Monsalve. I've been 4 years as well in the Edge team here at Roche, an awesome team. And yeah. So
Roche, to go back to the question. So we are a pharmaceutical company. It's quite an old one. Roche has been around 429 years now. We are a leader in healthcare research and development. We have a few prizes on our belt, but not in the tech industry. What connects us to the tech industry is more the diagnostics side of things, where we have lots of laboratory components that need to be tied up in laboratories for diagnostic processes and so on, or other digital products for helping pharmacies, doctors, and so on. You probably used some of our products in the past. In particular, there was this little event called COVID a few years ago. We produced a lot of the PCR tests and self-tests that were used during this unfortunate event that we are all trying to forget. So you probably used some of our products. How software was done and deployed to our customers in the past was kind of every product team was working in isolation, managing their own software, their own infrastructure, logging, monitoring, security, lifecycle, and so on. That was not very scalable, and we started a process to abstract all the infrastructure, all the monitoring, logging, security, lifecycle, and so on, to help the team focus on what they need to do, bringing values to our customers, and abstracting all the complexity of managing the infrastructure. Going back to the talk of earlier. So who we are, the Edge team. So we are in an internal platform team. We're not actually selling a product outside. We're providing this product to all the teams that are actually creating Roche's product. We are managing a large number of Kubernetes clusters all around the world. You can see this small animation which shows our fleet management console. We are deploying to various environments, laboratories, hospitals, pharmacies, doctor practices, and many more. The QR code is for a talk from last TalosCon in London, where we explore how our team started approaching Talos and how we onboarded and why. If you miss the QR code, it will be brought back at the end of the talk, so don't worry if you missed it.
Okay, so what was the starting point when we started our journey to AirGap? Right, so we were deploying all of our applications and components using pure GitOps practices. And if you are using GitOps as well, then this diagram will look probably quite familiar for you. So in our case, what we have was a Git repository. Here, what you can see the edge template. Basically, here what we have is all the components that are going to be deployed in our stack. Okay, like the CNI, ingress controllers, all the things. And in this repository, when we have to update any of these components is where we do all the changes, right? Then what happens is that when a new edge cluster is created in our fleet management system, basically the very first thing that we do is we create another Git repository, which is going to be used for GitOps purposes for that particular cluster, right? And then we use a GitOps templating tool, which is called FoxOps, to copy this edge template into the Git repository. And then what we use is a FlagCD for our continuous delivery. Okay, so we have a Git repository custom resource there that is connected to this GitOps repository to pull all manifests and then deploy all the components to the Kubernetes cluster, right? And by the way, about FoxOps is an open source tool that our team is developing and maintaining. So we gave a talk 2 years ago in KubeCon North America. So if you are interested in knowing how it works, you can check that out and you can use it.
So the AirGap challenge. So earlier in the talk, there was a bit of discussion about complexity and where it emerges from. In this case, we had another type, which is government regulation. There's a lot of things about data privacy, where data can and cannot go, especially in the medical field, because obviously it's very sensitive data. So this didn't come out of nowhere. Teams for various products more and more started coming to us and saying, hey, we're trying to go to these countries, to these companies, but they want us to cut the cord. So that was at that point our problem. We needed to be able to deploy to these clinical and laboratory settings without any outbound internet connectivity. So we still had the same requirements. We need to be able to be fully functional without disconnection to our fleet management platform. We needed to be able to do all the lifecycle, perform secure upgrades reliably. We needed to be able to deliver new products without the connectivity again. And of course, we needed to have a resilient platform. We didn't want to have problems when surviving power outages or reboots that we didn't plan or anything like that. And finally, what we really wanted was to have a unified platform. We didn't want to have to break our platform into a connected one and a disconnected one. We wanted to be able to reuse as much as possible and keep that away from the interface that we're providing to our users. So we really wanted to abstract it all and hide all the dirty secrets behind the Kubernetes interface that we're providing our users.
Okay, so what was the problem with the initial solution? Well, that it has to be connected all the time to Git repositories, right? And this was something that we needed to solve. So as a first step, we decided to switch to gitless GitOps, which for us is not a buzzword anymore, but is becoming really the industry standard of applying continuous delivery using OCI artifacts, right? So then here, this is the diagram that looks pretty similar to the previous one, right? And here, by the way, we are omitting some components for the sake of simplicity. But what we did basically was in the GitOps cluster repository, we created a pipeline that every time there is a change there done for this particular cluster, then it generates and pushes an OCI artifact to our hardware registry, which is in the cloud still, okay? We'll tackle that in a moment. And then in the Kubernetes side, we just switched the Git repository to an OCI repository custom resource, connecting the source to this OCI artifact and tag latest, so that every time the OCI artifact is modified, then Flags can get all the changes and then deploy again everything to the Kubernetes cluster.
So that's great. We now have something that we can deliver to the cluster, which doesn't require the connectivity anymore, but we need somewhere to store it on the cluster itself. There's many ways to do it, many offers for on-the-shelf solutions, but we needed to find the right one for our case. As I mentioned earlier, one of our key requirements was we wanted to have a unified platform. We didn't want to have something that was either disconnected or connected. So we needed to find something that would work in both cases. We also needed something that had more reliability, and that meant that having an in-cluster registry for us was not an option. We really wanted something that didn't require the full stack to be running, to be there. We wanted something isolated. So that's why we decided on running Zot as a system extension and leveraging containerd mirroring to basically redirect all the traffic from containerd to our local registry. So this happens both in connected and disconnected cluster. This means that if a connected cluster needs to turn air gap, it's possible because everything is already cached locally. We use on-demand sync for Zot to bridge the gap to our fleet management registry, where we are using Harbor, and that's it for everything, right? Not quite. We still have one question. We have the source controller for Flux, which still needs to access OCI artifacts. How do we deal with that?
Okay, so what about the Kubernetes traffic, right? And this was another great question that we needed to answer. Right, because yeah, with the containerd mirrors, we have already resolved the part of the operating system, right? So Kubelet was able to pull images from the local registry. It was able to create pods and so on. But what happens with the Flux source controller that is running in the end in the Kubernetes pod network, right? It has to connect also to the local registry that we have deployed as a Talos system extension. So yeah, what to do, no? One option could have been maybe to expose the Talos system extension, the local registry, into the cluster IP, okay? And then point the source, the Flux source controller, the OCI repository, to this cluster IP. But the problem with this is that then we would be increasing our attack vector, and it would be in the end, we will be turning our product in a less secure one, right? Because we would be exposing the Zot registry out of the cluster. So what to do, no? The thing is, we were running already Cilium in all our clusters, and we were already leveraging Cilium service mesh. And here is where the Cilium magic kicks in, right? But I want to step back for a moment, and I want to make some questions back to you guys. So is there here in the room, yeah, anybody that is already have worked with Cilium or is already running Cilium in their Kubernetes clusters? Okay, that's a lot of people. Okay, and then also from those of you guys, is there anybody that is using any maybe Cilium service mesh advanced functionality, like for example, Cilium network policies, applying any kind of layer 7 filtering or something like this? Okay, still some hands there. And is there anybody that is using any custom Cilium envoy configs? Okay, no, one hand. We have one hand, two. Okay, so then maybe this feature sounds familiar to you, guys. If not, then yeah, you will see it today. So the feature that we were using was the Cilium network policy traffic redirect. Okay, and we were already using that feature already for other purposes in our stack. And today I will not go in deep about how it works. Okay, we gave a talk last year in KubeCon Europe about it. So if you are interested in knowing how it works, go and check that out. Okay. Or we can talk about that after the session. But in short, what you can do with Cilium is you can create a Cilium network policy, and then you can redirect certain traffic that you are interested in into a Cilium envoy config where you can apply any kind of envoy proxy that you might need, right? And this is exactly what we implemented here. So in the flag system, where all the flags controllers are running, and especially the source controller, which is the one that we wanted to connect to the local registry, to the thought local registry, then we created a Cilium network policy that for all the traffic with destination to our harbor registry that is in the cloud, forwarded, instead of sending the traffic all the way down to the Linux networking stack, it was forwarding the traffic to an envoy listener that we had defined in this Cilium envoy config that you see here. And basically there, we have an envoy proxy configuration that is forwarding the request to the local host in the port and IP where we are running the local registry. Then what happens is what Matt already commented. Then if the image is there, it will be served right away. If not, then it will go all the way upstream to our harbor registry in the cloud, pull it, catch it, and serve it back. And then for air gap clusters, then what we will do is we will preload all the images there already.
So we've talked so far about how we are actually architecting the system itself to be able to run in this air gap mode, but there is still one aspect that we kind of need to cover, and it's actually delivering whatever we need to the edge. So for that, we are leveraging our fleet management console to pull what is needed to be delivered on the edge cluster and bundle it in some artifact that our field service engineer are able to download on their laptop to bring to the cluster where it has to be shipped. So to ensure that we have security, of course, we want the right bundle to go to the right cluster, and we don't want any bundle to be delivered there. We're using signature on the data that is being provided with a private-public key shared between the fleet management and the edge itself to ensure the validity of the bundle. And then we process it. We push every image that we need in the registry, local registry. And we also have the ability to include Kubernetes manifests if we want. That's especially important for us since we have a few life cycles which are triggered by manifests and operators. So that's kind of the whole concept. And we're going to try to demo that a little bit. So to explain a bit what's going to happen, I have running, hopefully still healthy, cluster running on my computer in a VM. It doesn't like my NTP, but that's fine. It's still running. And the next thing I can show you is basically our node console. So this is a small layer that we built into a system extension to help our service engineers to interact with our cluster without having to go in the terminal and so on. So they can just plug into the network where the machine is running. We don't always have a screen or a keyboard on the machine that's actually running the cluster, and they can have access to a few basic information. One thing that we don't see here is that the machine in which we run these clusters have two network interface, and that allowed us to have also an edit mode for the configuration, where basically if they plug themselves directly on the machine with a cable between their machine and the edge, they can actually edit the configuration. So if we look just a bit, I have exposed this time the registry to everything on my machine, so I can actually access it, which is not the case in regular deployment. But I can check, for example, if there's...
Maybe make it a little bit bigger.
Yeah, probably. So if I do a quick crane catalog to check what I have, and I'm specifying here a little grep with Nginx because I have that in the bundle. I can actually also check netshoot because I think it's also in the bundle. There's nothing. So we're all good with that. Still larger? Okay. Let's rerun. Is that enough? Oh, no, still not. Okay. Yeah. If we switch back to this console, we have the ability to select an upgrade bundle. So I have one here prepared, as you can see. Let's upload it. And we can actually trigger things. So we're going to upload it. We're going to process it. It should not take too much time, finger crossed. I prayed a lot to the demo gods this morning. Yeah, I prayed a lot. And it worked. So what we have here now is a small QR code that our service engineer can scan. This redirects them on our fleet management platform. This will register in our system that the bundle has been applied. So when we do the next bundle, we don't have to deliver everything. We can do a diff of what is already in the cluster, what is not, and make it a bit simpler. And if we go back in the terminal and check for Nginx, we have now this new one. And if we check netshoot, same, we have this new thing. And yeah, if you check the registry, it's indeed like 1040 to 135. It's definitely our VM. So everything worked. Brilliant. Let's go back to the presentation.
Okay, so then some conclusions and key takeaways, right? And for us, it meant that a unified architecture for both connected and air-gapped environments is feasible. Also that moving from pure GitOps to gitless GitOps is a key enabler for that. And leveraging modern technologies like eBPF, Cilium, Envoy, and so on can even allow for almost transparent solutions. And then finally, that with the right design, this air gap or cutting the core does not mean compromising things like security and reliability. So yeah, then here we are giving you the QRs to the talks that we have mentioned already in this session. First one is for this FoxOps GitOps templating tool. The second one is for the Cilium network traffic redirect. So if you want to know in detail how this works, you can go and check that out. And the latest one is the one from our last year presentation here in the Talos Con. So there you will see more or less our fleet management is kind of a tour of our fleet management and how we integrated Talos in our whole stack. So yeah, that's pretty much it for today. In case you want to talk in details or you want to know more about anything that we have shared here today, we will be here the whole day. So just stop by, say hello, and it will be a pleasure to talk to you. Thank you very much.
And now we left plenty of time for questions, which was the plan. So let's maybe, Sean, the mic.
Questions?
There was one here, Sean.
Yeah. Yeah, Eric?
Yeah, hi. I have a question. The solution that you implemented with the bundles, the cloud platform, and the edge solution, is that a proprietary Roche solution, or did you use commercial off-the-shelf solutions for that?
So at the moment, we are using something internal. It's very simple. We didn't want to overcomplicate it. We started deploying that in our latest version of our clusters, but it's not in production yet, and we're still considering some of the requirements and evolving the solution. So we are not necessarily locked into our current implementation. We really wanted to make sure that at one point, if we find the right commercial off-the-shelf implementation, we can easily switch to it. But at the moment, it's internal.
Any plans to make it open source?
That I don't know yet. But to be clear, it's not overly complicated if you think about it in terms of you're pulling the images, right? Then you need to store them somewhere, securing it. You get a digest of an archive which contains all your images. You make sure that you have the signature. Then on the edge, you make sure that the signature matches whatever is received. Like, it's not magic either, let's say.
Hello. I have a question. The ZOT registry extension,
yes.
Is this publicly available, or is it publicly available?
Yeah, ZOT is an open source project.
No, is it an official system extension for Talos, or how are you doing it?
No, we are building the system extension.
So you're rebuilding all system extensions, or how are you extending it? I mean, I'm asking because we are doing a lot of extensions too, and I'm not so happy with it, how it works, so...
I don't know publicly, like, distributed, but we're basically building the extension like ourselves in our CI, storing it on a private registry, and we're not actually using the factory, we're running the imager ourselves because we have different private extensions that we don't want to, for IP reasons, we can't really have on a public registry. So yeah, we are forced to have that part. So it's easy for us to build it there, and yeah.
I have a similar problem, so maybe we can discuss about it, and maybe we find a way that it's
for sure.
easier to add extensions that you can't share with everybody, instead of then rebuilding the whole system.
So the last time we discussed it, if I'm not mistaken, the discussion was around, you can run the factory yourselves and have the configuration.
We do, and we're doing some really dirty stuff with the extension.
we do the dirty stuff directly with the imager. So
maybe we should stop doing dirty stuff. Yeah. Thanks.
Other questions?
Sean in the back.
So, fantastic solution. The weird niche thing that really interests me is the QR code for updating your workflow systems back into base.
Yeah.
Great air gap solution. Is there any sense in which you use that in the opposite direction, so that you can ensure that workflow information is included as part of upgrade logs in the systems themselves, or would that be an attack vector you wouldn't go with?
So in the other direction, it doesn't really make sense in my opinion, because we already have the ability to include manifests and stuff like that in this bundle, which basically get picked up by our operator in the cluster to do whatever action we need to do. So
sure then, but okay, so in the way that you do have the QR, what information is within that QR code? What information are you updating into the workflow?
it's at this point, it's just ID of the bundle, a few basic information, but we are not returning logs or metrics or anything like that via the QR code.
Yeah, go on.
How do you do observability on this? Or that's just a black box running out there? Or?
So we have a local observability stack. Obviously, we can't access it from outside, but the idea is if you have a customer where something is running air gap and you have problems, there is a way for them to basically download a bundle with all the support information, send you the bundle, and you can have a look at what's going on in the server and figure out what step needs to be taken to fix it.
You basically have some sort of option for them to say, hey, can you package together a lot of...
Can you package, well, if you do this option, then you kind of package together shitloads of observability metrics.
Exactly.
Way back.
Yeah.
and that is a bundle that they can extract from the system and send to you.
Yes.
All right.
Hi there, interesting talk. Have you evaluated the, I don't know which version of Talos introduced it, but the Talos image cache as a possible path forward?
We are using the image cache for the installer, actually. But at the moment, it doesn't help for a few reasons. First of all, we can't really update it yet.
I'm unfamiliar with it myself, but I just looked at the documentation, and you can actually connect external storage media, and it will update the local cache.
So not with the current version we're using.
Yeah, we have the same problem.
And yeah, the process of releasing we're not on the latest. If you see what I currently have running here, I'm still on 110, right? So we also have quite a long process to adopt a new version and so on. So we wanted to be as independent from that feature as possible. But we're using it for the installer in the beginning because we wanted to make sure that we had it available. And we are not running the extension in the ISO when we deploy the ISO, obviously. So that was important for us, yeah.
Thank you.
Then if there is no more question, thank you for joining us today. And have a good day.